Hello friends, in this video we are going to see the programming skill development laboratories one more assignment, that is LED blinking using PIC microcontroller. For this assignment we will require softwares like MPLabX IDE version 5.40, PIC loader and USB to serial communication port. MPLabX IDE, it is a specialized IDE used to code embedded C programs using the compiler of XC8. We are going to compile that embedded C program and using PIC loader. PIC loader, it is a type of bootloader which can be used to dump the hex file into your PIC microcontroller based hardware kit. USB to serial communication port is used to transfer your hex file from CPU of the system to the memory of your PIC microcontroller based hardware kit. PIC microcontroller based hardware kit, it is a specialized kit designed for the second year students of IT and computer department by different manufacturers, and on that kit they have fitted PIC 18F4550 microcontroller. There is one LCD display, there is a LED panel, a reset button, on off button, inbuilt temperature sensor, inbuilt ADC, inbuilt LED panel, and it has one reset button, it has a battery backup, it has USB to serial port. We are going to attach this PIC microcontroller based kit using USB cable to our CPU of the system. Now in front of you I have displayed embedded C code of LED blinking. The very first I have included a header file which is required for compiling of this code, that is p18f4550.h. Then I have written a delay function with a variable called time. Delay function, it is a specialized function of embedded C or C programming language which causes the compiler, which causes the processor to halt for some time, and after that particular time your processor will display the output back. The delay function is everywhere used most of the time. It is an inbuilt function in most of the advanced compilers and advanced processors, but in PIC we are going to write a separate delay function using one variable, that is time variable. So second line of program is a void delay one variable unsigned int time, curly brace open. Again I have declared two variables I and j. I have written one for loop for I is equal to 0, I is less than time, I plus plus. Here time is the argument which is accepted while function declaration. Whatever value you have passed at the time of call of delay function, that time is going to pass as it is to the first for loop. For example, if I call the delay function for 200 times, then your I variable will, the first for loop of I variable will run for 200 times. The second variable I have used in the for loop, second for loop, that is variable j. J is equal to 0, j is less than 5000, j plus plus. Here you can take any random number. This is a specified delay function which is used to generate a delay of 1 microsecond. This, if you change the value of time and if you change the value of j in the second for loop, accordingly the delay time is going to change, curly brace close. Then we are going to declare a main function. Here the kit which we having in our institute are inbuilt LED panel which is connected to the port C of your PIC microcontroller. So port B of your PIC microcontroller. So we are going to initialize port B into output mode using trace register. So after main function I have written one line, that is trace B equal to 00. Here now as I have already told you, the LED panel of our kit is connected to port B of your PIC microcontroller. So it is an inbuilt connection by the manufacturer himself. So we are going to initialize port B into output mode, and as we are blinking the LED panel, or as we are blinking a LED, the blinking of LED means we are going to keep the LED on for some time and off for some time. This is called as blinking of LED. So the meaning of on off LED means we are going to pass the value 1. Value 1 is corresponding to on, and in hexadecimal value 1 is represented as FF. As you have already known that the value or the result is always there in the lat, so we are going to pass the value FF. The meaning of FF means value 1. So we have passed this value 1 to lat B, as the LED panel is connected to port B. On next line I have written an infinite loop. The infinite loop in the embedded C can be created using while 1. While 1, it is an infinite loop in embedded C. It means that till your kit is on, till your CPU is on, till your system is on, your LED panel or your LED will keep on blinking. In the infinite loop, very first I have changed the value 1 in terms of FF to the lat B, that is to the port B where my LED panel is attached. Now I am going to invert that value using inversion sign on the keyboard. So again on next line, lat B is equal to not lat B. Initial value of lat B is equal to FF. Now after this inversion value, after that inversion operation, the value of lat B will become 0. Then I have given the call to delay value, call to delay function for 200 times. As per your wish, as per your requirement, you can keep on changing the value of delay function. This call will be received by the delay function, and now the variable time will have value equal to 200. Approximately this loop will continue for almost 1 microseconds, and your LED will start blinking after executing this program. After successful execution of this program, the hex file will be generated, and with the help of USB cable we are going to dump that hex file into PIC microcontroller based hardware kit, and using the predefined steps of PIC loader we are going to check the output of the LED blinking. Thank you.